Hi guys, welcome to this video, and in this video we'll be talking about pointer to a pointer and 2D or multi-dimensional array. So as it states here, pointer to a pointer and multi-dimensional array. So what is a pointer to a pointer? A pointer to a pointer is a form of a multiple indirection or a chain of pointers, that is, you have more than one pointer. Normally, a pointer contains the address of a variable, but when we define a pointer to a pointer, the first pointer, that is the new one, will contain the address of the second pointer, which also points to the location that contains the virtual value of the variable. So if you look at this diagram, you have the first pointer, the new one, you have the second pointer, the older one, and you have the variable. So naturally, when you have your variable, you have the value and the variable address. The first pointer is going to point to the variable address, okay? And you can also get the value of the value using just one asterisk. Then the second pointer that you created is going to point to the address of the first pointer and is going to hold the value, okay? So when you want to declare a pointer to a pointer, you use double asterisk. And also note that a variable that is a pointer to a pointer must be declared as such using asterisk asterisk, okay? So this is done by placing an additional asterisk in front of its name. For example, the following declaration declares a pointer to a pointer of type int, that is this. So this declares a pointer to a pointer with the type of int or an integer. So without much ado, let's get to it. So I'm going to use Visual Studio Code for this. The reason is what we want to describe here is going to be quite long, so I don't want to go through the stress of moving back and forth in the VIM or Vim editor. So let's do everything in Visual Studio Code so that you can see it properly in one place. So the first thing we'll do is to declare our header, which is very important, standard input.h. Then we create our function int main. Then don't forget the return. So let's always have this. Okay, so what are we doing here exactly? What we are doing is we are going to declare a variable and the first pointer and the second pointer. So let's declare that the very first variable is going to be int num, okay? Then we'll also have, so they have to be the same type. So int ptr1, this is going to be pointer 1, int ptr2. So you see, you have to use the double asterisk before it to tell that it is a pointer to a pointer. All right. So now that we've declared it, we can now assign a value to the first one. So integer, let's make integer, let's just call integer 7,000, okay, or 700. So that is the value of the pointer integer, all right? Oh, sorry, that is the value of the variable num. So variable num is 700 now. Now that we've done this, the next thing for us to do is to now take the address of the variable num. So we say ptr1 is equal to the address of num, okay? Now, for the second one, the second pointer, we say ptr2 is also going to take the address of ptr1. So what have I done here now? What I did was I declared the variable, so variable num and pointer 1 and pointer 2. Then I set the value of num to 700. Then I collected the memory address, okay, the address of the variable num. I assigned it to pointer 1. Then I also assigned the address, okay, is the address of pointer 1. I address it to pointer 2. So let's print out our result and let's see how it works so that we can understand what is happening in the background. So let's access the value of num using the pointers. So let's say access the value of num. So there are three ways to access the value of num. The very first one is the one we all know already, okay? So we say, I just want a new line, or let me take this here, the value of num is, So the value of num is just the way we know it, is an integer, so we use d. Then we use variable num. But also, we can access the value of num using the pointers, all right? So let's try that. So printf the value of num using ptr1, okay? So we're using ptr1 to access the value of num, and that is also an integer, and we are going to use the indirection operator ptr1. So let me duplicate that. Now, we can also access the value of num using ptr2. So we say ptr2 and you use the double indirection operator. So you see that it is because this second pointer is pointing to the first pointer, you can also get the value of the initial number. Okay, so look at the three variables, three printfs we have here, and let's see how they work. Let me clear the outputs. Okay, so let me rerun this. Okay, sorry, I need to, let me clear. There's some issues with, oh yeah, I'm using and instead of percentage. Sorry guys, so it's percentage. So I'm also going to put a new line here, so we have everything on a new line. Okay, so good. We'll save this and run this now. So what we are doing is we are trying to access this 700, the value of num, using the pointer 1 and the pointer 2, using indirection operator of a pointer. And as you can see, the value of num is 700. The value of num using pointer 1 is 700. The value of num using pointer 2 is 700. Now, we've been able to get the value. How about the address of num? So let's do that. The address of num. So now let's create another block. So I'll say address of num. So we want to access the address of num now. So let's go again. Printf. Okay, then we say the address of num. Okay, so address of variable num, accessing the address of variable num. So we use the indirection operator p. Sorry, we use the variable specifier p. Okay, so we are trying to get the address of num, but also we can get the address of num from the pointers. So we say printf the address of num using ptr1. Okay, p, then this is going to be ptr1. Then also, let me duplicate. We can also get the address of num using ptr2. So how do we do that? We use just a single indirection operator. Address of num using ptr2. So let's see what it prints out as the address of num. So let me give that 2 lines. Okay, so let's run this. Sorry, there's an error with the code. Printf. Okay, let me rerun this. So let me put this on new line. All right, then this one too is supposed to be on a new line. So let's rerun this. Oh, sorry, I spelled printf wrongly. Sorry guys, printf. Okay, so let's rerun this. Well, let me clear before I do that. Now, as you can see, the value of num is 700 all through, even when you use the pointers, and also the address of num, which ends with 984, we've been able to get it using the pointers. So you see, the idea of the pointer is the second pointer is going through the first pointer to access the variable. So you see, that is the idea of pointer in a pointer. So we've been able to access the value of the variable using the second pointer going through the first pointer. So that's the idea of pointer through a pointer. So let's check out another concept. So the concept we'll be checking out is also we can access the value of pointer 1 using pointer 2. So let's try that. So let's say value of pointer 1. Okay, let me just make this same. So I'll say value. So value of num, address of num, value of pointer 1. So to get the value of pointer 1, we can do it directly by saying print f. So we say print f, then the value of pointer, ptr1. Okay, let's say pointer ptr1. Okay, so the value is going to be percentage %p. Let's put a new line there. And how do you access the value of pointer 1? You simply say ptr1. But also, we can also get the value using the pointer 2. Okay, so I duplicated that. So the value of pointer ptr1 using ptr2. Okay, so it's simple. We use the indirection operator and turn that to 2. So what we are doing here now is we are trying to access the value of pointer 1. Okay, so the value of pointer 1 is this, and we also want to get the value using the indirection of pointer 2, since pointer 2 is pointing to the address of pointer 1. So let's try that. So let me clear. We have a lot here now. So let me rerun this. So we are working with the third one. So you can see the value of pointer 1 is 734. Okay, and remember, pointer 1 points to the address of the variable num. So you see, that is why the value of pointer 1 and the address of variable num is the same. And also, the value of pointer 1 through using pointer 2 is this, because pointer 2, the value of pointer 2 is pointing to the value of pointer 1, which happens to be the address of the variable num. All right, so let's proceed, guys. We can also access the address. So we can also access the address of pointer 1. Remember, the value of the address of pointer 1 is what we refer to using pointer 2. So let's do that. So let's say address of pointer 1. Okay, pointer 1 is ptr1. So let me put that here too, ptr1. Okay, so that it's descriptive enough. So let's print f. We say print f, the address of pointer ptr1 is. So how do you get the address? You use format specifier p, then you use this ampersand ptr1. This is how we get the address. But remember also that the address of pointer 1 is the value of pointer 2. So the address of pointer 1 using pointer 2 is simply pointer 2. So let's run this code. Let's use our new line so that we have everything on new line and it's clean. New line, new line. All right, let's run this. Let me clear, then rerun it. So I've cleared, and I'll rerun it. Now you can see the address of pointer 1 is this, and the address of pointer 2 or the address of pointer 1 using pointer 2 is this. That is because pointer 2 is storing the address of pointer 1. Look at it. This is where we did it. Pointer 2 is storing the address of pointer 1. And that is why we accessed it like this. So when we got here, when we used the ampersand to get the address of pointer 1, all we did was just to use PTR2 to get the address of pointer 1. Okay, so let's check out what we can do with pointer 2 itself. So pointer 2 is the last kid on the block, this guy, which is the last one. So since nothing is pointing to it, all we can do is we can access the value and the address at once. Okay, so let's say working with pointer 2, which is PTR2. Okay, so the first printf, we will just say the value of pointer PTR2 is, so format specifier P, then new line. Then we are accessing the address. To access the address is just simply as saying PTR2. Then let's access the address of pointer. So we say printf the address of pointer 2. So the address of pointer 2, which is PTR2, is P. All right. Then we use the ampersand operator to get the address. So let's run this and see what we have on our code. So I'll clear everything here, then redo it. Let me put this on a new line again. Let me clear this and rerun it. So you see, if I was doing this in the VIM editor, it's going to be very stressful. Okay, so you see, this is the value of pointer 2 is this, and the value of pointer 2, PTR2, the address of pointer 2 is this. So basically what we have just done here is we assess the value of the variable using two different pointers. The first one is a single pointer, the other one is a pointer to a pointer. Then we do the address of the number, and we got the address using a pointer and a pointer to a pointer. And we also use a pointer to get the value and address of the second pointer, and we also did that for the second pointer after the initial pointer. So guys, I just hope that you understand what has happened here. Let me show you my screen again. So for initially, what we did was we declared a variable number, declared a pointer, then a pointer to a pointer. The first thing we did was we set the variable to 700, then we assigned pointer 1 to the address of the variable, then we assigned pointer 2 to the address of pointer 1. And you know pointer 1 is already pointing to the address of the variable. So it's easy for you to access the value of pointer 1 of the variable num using any of the pointer. So also you can access the address of variable num using any of the pointer, which we did here. Then we went ahead to also show you that the pointers are connected, and we checked the value of pointer 1, and we also checked the value using pointer 2. So also we checked the address of pointer 1 using itself, pointer 1, and also we use the value stored in pointer 2, which happens to be the address of pointer 1. Then also we worked with pointer 2 itself by assessing its value and assessing the address of its pointer. Okay, so let's run this one last time and you see everything on the code editor. So I clear, then I run this. So this is it on pointer to a pointer, guys. This is the result. I'm going to make this code available so you can run it once and you can understand. So guys, let's move to the next one. And what we'll be discussing next is multi-dimensional arrays. All right. So guys, let's move. So guys, let's talk about a multi-dimensional array in C programming language. Back to our PowerPoint. So a 2D multi-dimensional array, a 2D array, also known as a multi-dimensional array or array of array, is a two-dimensional array that's also known as a matrix. You see, it has almost 4 names. So a matrix can be represented as a tables of rows and columns. That is, you have the type, the array name, then the rows and the columns. So without talking too much, let's get to it. So I'm still going to use this editor. So I'm going to use this editor, this VS Code, instead of using the VIM. But anything I do here can be replicated on Vim editor. I just find this more flexible to work with. So I'm going to delete everything we have inside, everything we did with the pointers. Then let's declare a multidimensional array, an array of an array, or a matrix. Okay, let's do that quickly. So to do this, we declare the data type int, then the array name, let's call this table, okay, or let's call this chess. Then the first thing is the rows, the numbers of rows you want. Let's say we want 4 rows. I will show this to you now. And let's say we want 5 columns. Now, when you do this, you have to open the curly braces, okay? So I'm going to break this down so that we can see it properly. That is why it looks like a matrix. The very first thing we do is we create the first array. So it's an array of an array. That is why you have the first curly brace, then you have another curly brace. So because we have 4 rows here, it means we are going to have 4 curly braces like this. 1, 2, 3, 4. You get it? Because we have 4 here, 4 rows. That is 1, 2, 3, 4. Now for the columns, it means we will have inside of the array, we are going to have 5 values. Okay, so let's do it. We say 1, 2, 3, 4, 5. You see? Now we can proceed. 7, 8, 9, 10, 11. Can you see they are all 5, 5 inside? 4 rows, 5 columns. So let's go. 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So if you check it, we have 4 rows, 1, 2, 3, 4, according to what we specified here, and we have 5 columns. How do I know? 1, 2, 3, 4, 5. So 5 values inside of the array. The next array we have 7 to 11. From 7 to 11 is 5 values. From 12 to 16 is 5 values. From 17 to 21 is 5 values. Now, you can see that this is how you create an array of an array. So if we put everything on one line, it will look like this. I just wanted you to see the matrix. So I'm trying to put them all on one line so that you see how it looks like on one line. So can you see how it all looks like on one line? This is how your array looks like on one line. But let's drop it back to one line each for each one of them so that you'll be able to see it all and understand why I have this value here, 4 and 5. Okay, so you can see it again. 4 rows, 1, 2, 3, 4, and 5 columns. Now remember from array, this first array is array 0, array 1, array 2, and array 3. Remember, in programming, we start counting from 0. So if you want to access this number 1, you say 0, 0. To access 5, you say 0, 4. But instead of doing it verbally, let's do it. Let's do it using a for loop, because it is only a for loop we can use to transverse or to get the values of a multidimensional array. And the kind of for loop we use is also the nested for loop. So we'll use the first for loop to get each of these respective values from 1 to 21, okay, and their indexes. So we'll get the index and the value. So let's do that. So our first for loop, so let's call this getting values, getting index and values of the array. So we go like this. So for int I, so instead of doing the int I here, it's better we declare the variables outside first. So I and j, this is a better practice so that we can use it directly here. Okay, so I is equal to 0, then I is less than, so I should be less than the row, so 4, then we increment I, okay, I plus plus. That is the first or outer loop. Then for the inner loop, we'll go again. So J is equal to 0, J is less than 5, then J plus plus. So what do we want it to do? We want to print out the index and the value. So we say chess. Remember, chess is the array name. So chess percentage %d, another percentage %d, and is equal to what? Percentage %d. You will see why we're using percentage %d now. So now that we have that, the next thing is to call them out. So I, the first variable, J, and chess. So the first one is I, the second one is J. So let me explain what we are doing here. So we want to transverse this array to get the index of each array and the value at each index. So we use the for loop. The first for loop is going to transverse through the row. The second for loop is going to transverse to the column. And we are printing out the indexes and their value. So let's run this. Okay. Oh, sorry, print F. Why do I keep making this mistake? So print F, clear. And let's rerun this. So let's bring this up. And as you can see, our array has transversed through everything, and you can see the value on your screen. So if I show it to you now, you see 1 to 21, and we have this here. Look at our array, 1 to 21. So it's telling you that at chess 00, you have 1. At chess 04, this one, you have 5. At chess 22, you have 14. So that is it on transversing the array, okay? So basically, it's pretty straightforward, you know, transversing the array and getting the values. So we can also print out our values, probably like a table, you understand, so that you can also see. So now we've been able to transverse through the array to get the indexes and their values, all right? So for what we want to do next, let me just copy this array, this for loop. I'll duplicate it. Then I will comment this one out. Let me close it. Yes, so I've taken that one out. So what we are doing now is pretty simple. So I'm just going to show it to you. So I want to just print everything out as a table. So D, new line. Don't need to put that there. So let's put some space here. Then we don't need this anymore. So yes, so chess is going to print. So we are printing out all the values of chess. So one by one by one. So just to prevent issues, we can do something. We can put a simple an if statement so that we get our new line. So we say if J is equal to 4. So 4 is our row. So anytime it gets to the row, it should go to a new line. So we should just print F. We should print a new line there. Okay, so new line. So what we are doing is we want to see all these numbers just the way they look here. We want to see them also. So we've saved that and let's run this. Oh, I think there's an issue with the code. Oh yes, I used the wrong one. So it's supposed to be /. Okay, /. So I've saved that again. Now let me run this. So you can see we've been able to print out everything in like a table. So you have 1 to 5, 1 to 21, just like we have it here. So guys, that is it. So we've been able to do this initially, And we've also been able to do this. So this brings us to the end of our class, or this particular series on pointer to a pointer and 2D arrays. So guys, I'm glad you are here with me, and I will see you in the next one. Precious out. Thank you.